Welcome to this Masterclass Explainer. I'm so glad you're here because today we're diving deep into the hidden chemical realities of electronic waste. You know, we rarely look past the sleek plastic casings and glass screens of our discarded tech, right? But today, we're going to do exactly that. We'll methodically examine the actual, scientifically verified mechanisms that make e-waste one of the absolute most pressing environmental and biological challenges of our generation. Let's quickly run through our syllabus for today. First, we'll define the e-waste crisis. Then we'll look at soil and water contamination, followed by the hazards of incineration. After that, we'll map out the anatomy of toxic exposure. And finally, we'll cover the global fallout. Okay, let's get into it. So what exactly do we mean by e-waste? Well, it's really just a popular everyday term for electronic products that are nearing the end of their useful life. Now, sure, a lot of these items can actually be reused, refurbished, or recycled. But, and here's the kicker, they become incredibly dangerous depending on their condition and how densely they're packed when we throw them away. The core issue is that certain components inside these devices contain materials that are inherently hazardous, posing a massive direct threat to both human health and our environment. And listen, we're not talking about some abstract industrial waste from a chemical plant. We are literally talking about our everyday household items. Think about your old computers, cell phones, televisions, maybe those ancient VCRs or stereos gathering dust. It's the copiers and fax machines from your office, right down to everyday electric lamps and batteries. When these incredibly common devices are tossed out improperly, the sheer volume and chemical density of the waste create a really severe, rapidly escalating threat. Moving on to part 2, soil and water contamination, the ground-level threat. Imagine this. When computer wastes are just dumped into a landfill without proper monitoring, a really dangerous chemical chain reaction kicks off. As rain and water filter down through those decaying electronics, it creates what we call contaminated leachates. And these toxic liquid leachates don't just sit there. No, they seep downward, steadily and systematically infiltrating our vital groundwater reserves. It's basically an invisible, silent wave of pollution happening right beneath our feet. To really grasp the gravity of this, let's look at a real-world case study, Gyu, Hong Kong. Now, this area became a massive, thriving hub for illegal e-waste recycling. But the environmental cost? Absolutely catastrophic. They were locally disposing of highly toxic acids and sludges, which are byproducts from melting down computer chips. This caused severe acidification of the soil. And worse, dumping these recycling wastes directly into the rivers completely destroyed the local water resources. It left the area facing acute water shortages. It's a tragic paradox, really. You're surrounded by water, but you can't drink a single drop. That brings us to Section 3, the hazards of incineration, chemical release. Now, there's a really tragic irony we need to talk about here. Uncontrolled fires happen a lot at landfills globally, sure, but the absolute most dangerous practice is the intentional open-air burning of plastics. And why do people do this? Literally just to recover tiny trace amounts of copper and other valuable metals hidden inside the wires. So, for a really small, short-term economic gain, we trigger a massive, devastating release of toxic fallout straight into the local environment. So the absolutely crucial takeaway here is understanding exactly which components harbor which toxins. When circuit breakers are destroyed, they leach out mercury. If you smash condensers, they release highly dangerous polychlorinated biphenols, or PCBs. What about older cathode ray tubes? Well, if you break that cone glass, significant amounts of lead ion dissolve right into acid waters. And when plastics that are treated with flame retardants or contain cadmium end up in a landfill, compounds like PBDE and raw cadmium leach directly into the ecosystem. Every single component has a very specific, very real chemical consequence. Let's transition to Section 4, Anatomy of Toxic Exposure, the biological impact. I want you to take a moment and really absorb this physiological map. It breaks down exactly how these heavy metals and toxic gases systematically compromise human biology. When we improperly throw away our electronics, we aren't just harming the earth, We are directly exposing recycling workers, local communities, and ultimately ourselves to a literal cocktail of elements that specifically target our internal systems. Let's break down exactly how these chemical attacks happen in the body. If we group these scientifically, the first thing we see is a direct, brutal assault on our neurological network. Lead exposure, for instance, causes severe brain and nervous system damage. And tragically, children are especially vulnerable to this, including severe damage to fetal development. Then you have mercury, which, whether you inhale it or ingest it, just ravages the central nervous system. Exposure to barium can actually lead to brain swelling and muscle weakness. And remember those PCBs we mentioned earlier from condensers? They cause profound nervous damage and trigger very noticeable behavioral changes. But it doesn't stop there. Our essential internal organs are relentlessly attacked too. Long-term exposure to cadmium, that causes irreversible kidney damage, loss of bone density, and it's a known carcinogen. Then there's trichloroethylene, or TCE, which severely impacts both liver and kidney function and actually impairs fetal development. Meanwhile, brominated flame retardants, or BFRs, are highly suspected of severe hormonal interference and reproductive harm. We're even seeing them show up in the breast milk and blood of electronics workers. Finally, dioxins and furans directly impair the endocrine system and cause significant liver problems. And finally, our very breath and our cellular structures are put at risk. Inhaling beryllium can cause lung cancer and chronic breathing difficulties, a condition literally known as chronic beryllium disease. Hexavalent chromium, or chromium IV, causes severe asthmatic bronchitis and actual physical DNA damage to our cells. Long-term exposure to arsenic, specifically the highly toxic arsine gas used a lot in tech manufacturing, leads straight to lung cancer. And perhaps the most common culprit? Polyvinyl chloride, or PVC. It's the most widely used plastic in electronics, and when it burns, it forms hydrochloric acid gas. Inhaling that gas causes massive acute respiratory trauma. Okay, let's move to our final section, Part 5, Global Fallout and Conclusion. So what happens when those uncontrolled fires or open-air burning operations actually take place? They emit just unbelievable amounts of toxic byproducts. Crucially, the vaporization of elements like metallic mercury, right alongside the release of extremely toxic dioxins and furans from those flame retardants, enter directly into the atmosphere. And here's the terrifying part. They do not stay local. They hitch a ride on broader global air currents. That means highly toxic byproducts are actively being deposited in ecosystems and communities many, many thousands of miles away from the original fire. I'm going to leave you with this final, somewhat provocative thought. In a world that is so intimately connected by wind and water, does throwing our electronics away ever truly mean they are gone? The reality is, the hidden chemistry of our discarded devices is something we will all eventually breathe in, drink, and absorb. It absolutely forces us to radically rethink how we consume, manufacture, and dispose of our technology. Thank you so much for joining me in this explainer today. Keep questioning, keep learning, and I will see you next time.